video is going to explain the marking points for the action potential, or the generation of an action potential, that is. I've done the action potential graph here, which I'll talk you through now before we look at the mark points. We can see at the bottom there at point A, this is the resting potential. This is usually around about -70, although you will see some differences maybe in the exams or in the books, but it's round about -70. I'll do a different video on how resting potential is maintained, so you can look at that one to see how. From there we see stimulation of the neuron around about point B there. What happens at this point is the stimulation causes sodium channels in the membrane to open, and sodium will move into the membrane, making it become more positive, because during resting potential the outside of the cell is positive and the inside of the cell is negative. So when these sodium channels open, the sodium moves in and makes it more positive. At this point here we see that we haven't quite reached threshold. We're seeing a change in charge, the inside of the membrane is becoming more positive. We call this part here generator potential. The red line represents threshold. This is usually around about -55, give or take. At this point, stimulation has become so great, the change in charge between the inside and the outside of the membrane has become large enough that we see an action potential being sent at this point, the red dotted line here. This depolarization continues to occur up through the area labelled C. This again, we see greater permeability of the membrane, sodium being moving into the membrane and becoming more positive, until it reaches point D, which we call the maximum action potential. This is around about +30. At this point, sodium channels close and the potassium channels open. Potassium then moves out of the cell, which means that the charge inside the cell becomes more negative because the positives are leaving. This continues, and we see the charge drops until we get down to point F. This is called hyperpolarization. This is around about -70, -80, and this is where we've overshot the resting potential charge and we've gone past it, we've become more negative. The reason for this is because the potassium channels are slow to close. At this point, moving up to point G, normal resting potential is maintained through the normal mechanisms of resting potential. This section here, this red bracket, represents the refractory period. During this period, we see that only one action potential is sent. The refractory period ensures that it only moves in one direction and that each of the impulses is discrete and separate. If we move over to the mark points for this, I'll just highlight some of the important parts. Stating that the stimulation of the neuron causes depolarization. Remember to say which channel is opening and when. Sodium channels open during depolarization and the sodium is moving into the cell, and that makes it become more positive. Remember to say that you are reaching threshold. It's at threshold that the action potential is sent, as I say, around about -55. Once we've reached that maximum action potential and we're talking about repolarization, so the action potential has been sent, we need to talk about the sodium channels closing and then the potassium channels open and the potassium moves out. That makes the inside of the cell become more negative. Highlight the fact that the potassium channels are slow to close and that this section here is called repolarization. If you're talking about the refractory period, remember to say that it ensures that action potential is only travelling in one direction and that they are discrete.